So as we saw in the last lesson, there can be some revenue or expense functions that ended up being quadratic when it was to the second power. Well, if you remember in quadratic equations, standard form of a quadratic equation is ax squared plus bx plus c, where a is the number in front of x squared, b is the number in front of x, and c is your constant. Well, because they're quadratic, at times we're going to be asked to find the solutions to those quadratics. And one of the easiest ways was this guy right here, the quadratic formula. Remember that from Algebra 1 and Algebra 2? X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this unit, we're talking about break-even analysis, which is when the revenue, the money coming in, and the expenses equal each other. So let's look at some examples. So these break-even points, we talked about those over the last couple of weeks as well. So look at this first example. It says, determine the prices at the break-even points for Picasso paints. The expense function E equals negative 3,500 times the price plus 238,000. That's the expense function. That's the cost for doing business. And the revenue function, this is money that's coming in. Revenue is equal to negative 500 p squared plus 30,000 p. We found that revenue function in our last lesson. To find the break-even points, this is when the expenses and the revenue are equal each other. So the break-even point occurs when the expense and revenue functions intersect. There are two ways to determine it using technology, which we're not going to do. We're going to use algebra. All right. Here's how we're going to do it algebraically. The break-even point can be found by setting the expense and the revenue functions equal to each other. So that's what we've done here. So the expense function is negative 3,500p plus 238,000. And that's going to equal the revenue function, which is negative 500p squared plus 30,000p. Now I need to solve this, but the issue is I have the variable p here, and I also have p to the second power, which makes it quadratic, which means we're going to use the quadratic function, the quadratic equation, quadratic formula, in order to find the solutions to this. So the first thing that we need to do, if you remember, if you have a quadratic equation, is one side needs to be set equal to 0. So either these terms all have to be moved over here, or all of these terms have to be moved over here. So what we're going to do in this, I'm going to rewrite this and show you exactly what happened in this problem. Negative 3,500p plus 238,000 equals negative 500p squared plus 30,000p. Okay, so let's look at this equation. I'm trying to solve this for p. So one of these sides need to equal 0 because it's quadratic. So what I'm going to do is I'm going to add 500p squared to this side, and I'm going to add 500p squared to this side, but I can't add it to either one of these because they're not like terms. So I'm just going to throw it here in the front and bring everything else down. That's gone and equals 30,000p. Now the reason I brought that one over here is to make this positive, and it's always easier if this first number here is positive rather than leaving it on this side and having it negative. I don't have this side equal to 0. I still need to move this guy over. So I'm going to subtract 30,000p from both sides. Which will make this side equal to 0. This will still be 500p squared. This will be now negative 33,500p if I put those two together, plus 238,000 equals 0. And now that I can see the number that's in the A position is the first coefficient, the number that's in the B position is negative 33,500, and the number that's in the C position is 238,000. And now I'm going to throw this into the quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2 times A. You should remember that from your Algebra 1 and your Algebra 2 classes. So the opposite of B. So this is going to take us a minute to find the solutions, but these are going to give us, when we find them, the break-even points. The opposite of B, so since B is already negative, I'm going to make it positive now. B squared, so negative 33,500 squared minus 4 times A times C all over 2 times A. And now that looks like a lot, but really you're just going to let your calculator do the work. And we're going to work on this one step at a time. I'm going to square this number first. I hope my calculator has room. It does. 1,1,2,2,2,5,0,0,0,0. That's what that is squared. Minus, I'm going to multiply all these numbers together. 4 times 500 times another 238,000 is this big long number here. So it's a lot of numbers, but your calculator is doing all the work. All over 2 times 500, which would be 1,000. So I need to get this, all this number that's under the radical, I need to get it all down to one number and then take the square root of it. So 1,1,2,2,2,5,0,0,0,0 minus 476 million is this number. Take the square root of that and you get 25,421,45. 33,500 still, plus or minus. Now I took that and took the square root of it. 25,421.45 all over 1,000. So this plus or minus sign, I haven't talked about it, but if you remember, that doesn't come into play at all in the problem until right here. And now you're going to work it twice. You're going to work the problem, this numerator with the plus sign, so you're going to add the 2 and then divide by 1,000, and then you're going to work it again where you subtract them and then divide by 1,000, and this will give us actually 2 break-even points. So I'm going to work it once, adding the 2 together, and I'm going to work it again where we subtract them, and these are going to give us our 2 break-even points. So let's see. $58.92. And the other break-even point, $8.08. Which, if we go back going back to the example, they put it on the graphing calculator and they came up with the same things. So these are the 2 break-even points, $58.92 and $8.08. Okay? Oh, here's their work. So using the quadratic formula, you get these 2. So the prices at the break-evens are $8.08 and $58.92. Okay? So the expense function for this product is this. E equals negative 2,000 P plus 125,000. And the revenue is this, Determine the prices at the break-even points for this product algebraically. So let's see what we can do here. So the expense function is negative 2,000p plus 125,000. We're going to set that equal to the revenue, which is negative 600p squared plus 18,000p. It's quadratic, so I have to get everything over to one side. So I'm going to add 600p squared to both sides. Take away the 18,000p. That's going to be negative 20,000p plus 125,000. Now that you have one side equal to 0, you're going to throw this into the quadratic formula. Your A value is going to be 600, your B value is going to be negative 20,000, and the C value is the constant, which is 125,000. And you're going to just throw these numbers in wherever they go in the formula. And out of the essence of time, I'm not going to work this, but if you work it, you would get $8.33 as one answer. So work this problem and see if you get $8.33 as one of your break-even points, and the other break-even point or solution would be $25. Okay, so work through that, and if you get those numbers, then you can be confident that you did everything right. Okay. All right. Moving on. Determine the revenue and expense for the Picasso paint products at the break-even points found in example 1, which was the $8.08 and the $58.92. So if you plugged in 808 for P, these are the break-even prices. So here's your expense function, and here's the revenue function, and all they're doing is taking the P value out in both of these and putting in 808, which is one of the prices that we found. So when you plug in an 808 into the expense function, you're going to end up with 209,720. When you plug 808 into the revenue function, you end up with 209,756. Now, these break-even points, because of rounding, don't come out to be exactly the same, but they're coming out to be close, approximately the same. So you can see they're within a couple $100. Well, actually, they're within $46. So the expense and revenue function for the other break-even point, which was $58.92, when you plug that in to the expense function and to the revenue function, this is what it comes out to be, $31,780 and $31,816. So this is within $36 of each other. So you can see that these two prices are the actual break-even points between their expenses and their revenues. So when the break-even price is approximately 808, which we did here, the expense and revenue values are close to each other. When the break-even price is $58.92, the expense and the revenue are also very close to each other. Okay? They're not equivalent, but they're going to be approximately equal to each other or close. So, all right. That is it for assignment 16.